All right, welcome back. So this time we're going to talk about machine learning pipelines. Before we get started, hit the like button, subscribe, hit the like button, share, and subscribe with anyone you know taking the AWS Machine Learning Associate exam. So machine learning pipelines encompass data collection and preparation, including pre-processing and feature engineering. Production systems require integrated approaches across the complete lifecycle from ingestion through deployment and monitoring. So data collection, let's go into this. All right. You need to ingest structured and unstructured data into data lakes, typically S3. You can stream data via Kinesis data streams or Kafka on MSK. Then you can load batch files with AWS Glue jobs or direct S3 uploads. Amazon SageMaker Ground Truth enables automated and human-in-the-loop labeling, supporting 2D or 3D images, video, and text annotations. This service provides with manual annotation, workflows, and automated labeling using machine learning. Oops, I went too far. All right, data prep. So data cleaning handles null values, deduplication, and type corrections. It balances bias detection, improves critical and classification tasks. Feature engineering can include normalization, encoding, and scaling. So something like SageMaker Data Wrangler can provide interactive exploration and cleaning. AWS Glue can handle batch ETL and scalable processing. EMR can run distributed processing with Spark and Hive. Glue Data Catalog can detect schemas and catalog metadata. Macy can mask data and protect PII. And something like Athena can query and analyze data, while SageMaker Lineage Tracker can maintain data lineage. All right, so security. With security in your pipeline, you need to use IAM roles and policies with least privilege access. From here, you can apply KMS encryption, VPC endpoints, and private link for secure data flow. You can additionally store data credentials in AWS Secrets Manager and then enable audit trails using CloudTrail and object level logging with S3. So what about model development? All right. You need to select algorithms from SageMaker built-in options like XGBoost or Linear Learner. You can use pre-built containers for TensorFlow, PyTorch, or scikit-learn. That's SCIKIT, scikit. Okay, for custom logic, upload container images to ECR. From here, you can create training jobs using SageMaker training jobs with distributed training libraries, including data parallel and model parallel. You can also use managed spot instances for cost savings and apply SageMaker debugger profiling for GPU or CPU to detect bottlenecks. Then you need to worry about hyperparameters. All right. So SageMaker automatic model tuning performs hyperparameter optimization using Bayesian, search, or hyperband strategies. You can monitor precision versus recall, bias versus variance, and model fairness via SageMaker Clarify. Then you want to look about ML ops. All right. So SageMaker Pipelines defines DAGs for training, validation, and deployment. SageMaker Experiments can track parameters, metrics, and models. SageMaker Model Registry versions and stages models from staging to production, and automate with step functions. CoPipeline or Jenkins becomes a part of your operations. Then you want to worry about costs, all right? So something like SageMaker AI here. All right, so how do you save costs? One way, spot instances. This can reduce costs up to 90%, usually about 50 to 90%. And you can monitor this using AWS budgets and Cost Explorer, as we spoke about other. And you can apply different tools to warm up and slow down, such as with the spot instances, make sure your checkpointing is in place. When you're trying to launch EC2s, you can have warm pools for faster retraining. Or I'm sorry, SageMaker jobs. My apologies. All right. So how do you deploy? So real-time deployment serves interactive applications like chatbots, batch deployment, and handles daily scoring, report generation. Async deployment can support non-blocking workflows. Serverless deployment can provide low latency, sporadic calls. Multi-model endpoints can save costs by sharing endpoints across models. You should use SageMaker Inference Recommender to right-size instances. You should auto-scale endpoints using CloudWatch alarms and SageMaker endpoint auto-scaling. And then you can apply SageMaker blue-green deployments for safe model rollout. Edge deployment. Okay. SageMaker Neo is an option to optimize models for inference on devices. With this, you can have AWS IoT Greengrass to deploy machine learning models to edge devices for local inference without constant cloud connectivity. Monitoring. Okay. So CloudWatch can monitor endpoint health. You can also use SageMaker Model Monitor to protect and detect prediction drift. You can have SageMaker Clarify to track explainability. You can use Macy and Guard Duty to identify user access anomalies. You have pipelines and A2I to enable feedback loop retraining, and then have QuickSight to track business metrics for ROI. When you're doing this, use logging and alerts in CloudWatch for instance health. Use SageMaker A2I for human-in-the-loop quality reviews. Store endpoint metrics like latency, error rate, and CPU usage, and enable automatic retraining when model performance degrades. So how does this work with the well-architected framework? So AWS's well-architected machine learning lens reviews workloads across the 6 pillars, right? This means operational excellence can cover ML ops, pipelines, and monitoring. Security can include KMS, IAM, VPC, and private link. Reliability can ensure auto scaling, spot recovery, and retry logic. Performance efficiency optimizes training and inference. Cost optimization uses spot, right sizing, serverless, and managed tools. And sustainability reduces idle resources and chooses green regions. Now, we're not going to build a pipeline, but you can see from here how one would look. But I want to give you that overview so that you know for the exam to remember some essentials. When there are questions asking about implementing production machine learning pipelines, optimizing training costs, deploying models safely, or monitoring drift, understanding the complete lifecycle from data collection through preparation, training, tuning, deployment, and monitoring demonstrates practical knowledge of building scalable machine learning systems, integrating AWS services across the operational excellence, security, reliability, performance, cost optimization, and sustainability principles. So, thank you for joining. Before you get out of here, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.